And welcome to our video on section 6.1 from the Red Book, Simplifying Fractions. With the simplest form of an algebraic fraction, we want to remember that we can have no common factors in the numerator or in the denominator other than 1 or -1. We also want to be very careful to remember that in a fraction, you can't cancel terms unless they are in factored form. So you're always going to remember to factor first to find the common factors that you can cancel. So, for example, if you have x plus y over x plus 2, you cannot cancel the x and the y because there's addition in between. This is often easier to illustrate with a number example so that you can clearly see. If I have 3 plus 4 over 3 plus 2, then we would not be able to cancel, right, the 3's because they are not in factored form. We know that if we simplified this fraction, it would be 7 over 5 instead of 4 over 2. All right, so we're going to start with our first example, and the directions tell us to simplify and give any restrictions. So in this first example, what I see is that we have a GCF in the numerator, and we talked about wanting to take out common factors before we simplify. So if I factor out the common factor of 7, I end up with 3x minus 2y in the numerator, and I already have a 7 in the denominator. This allows us, now that we're in factored form, to cancel out the 7's and reduce the answer to just the simplified form of 3x minus 2y. In this example, there are no restrictions because there's no variable in the denominator. So again, what we're going to be looking for is a variable in the denominator. And in this case, we did not have it. So if we go on to example number 2, once again, we see a GCF in the numerator. So I'm going to factor out the 3, and I'm left with the quantity of c minus 8. I also have c minus 8 in the denominator. That means that I'm going to be able to cancel out the common factor, and that's just going to leave me with a simplified form of 3. However, in this example, we did have a variable in the denominator, so we will also have a restriction. In this case, the restriction is based on what we learned when we did literal equations in the first semester. We know that we can't divide by 0, so when we have a variable in the denominator, we're going to take whatever's in the denominator in factored form, set it equal to 0, and then once we solve, in this case by adding 8, we're going to say that's what c cannot equal. Because if c were equal to 8, then we would have 0 in the denominator. So from the beginning, you can write the c minus 8 cannot equal 0, and that might be a little bit easier. All right, so in example 3, we have another situation where we want to simplify, and here we're going to be able to factor a common factor out of the numerator and the denominator. So in the numerator, I can take out a 2, and in the denominator, I can take out a 4. Now again, reminder, we can't cancel the a's because they have addition and subtraction, but what we can do, just like we would reduce 2 over 4, we can cancel here, and then our simplified answer would just be a plus 3 over 2 times the quantity of a minus 3. Now with these problems, we can leave our answers in factored form. There's no need to distribute the 2 back into the a minus 3. But what we do have to remember is to look for a restriction. So in this case, we once again have a variable in the denominator. We can say, oh, a minus 3, and again, we can take it in the factored form. A minus 3 cannot equal 0. And when we add 3 to the other side, we're going to get, oh, therefore a cannot equal 3. So again, our simplified answer is the first part, and then the restriction is the second part. So the factoring will get progressively more difficult. So here we see that we again have a GCF in the numerator, but in the denominator we have the difference of squares. So we can factor to x minus 3 times the quantity of x plus 3. And again, as a reminder, the order there doesn't matter. So what I see is that I have a match, right, in the x minus 3. I'm going to be able to cancel, to simplify, any common factors that I see in both the numerator and the denominator. So my final answer is going to be 3 over the quantity of x plus 3. Just a reminder, don't be tempted to cancel those 3's. We can't do that because it's not in factored form. Here's another thing that we have to remember, and I think we saw this in example 2 as well, but we have to remember that our restrictions come before we simplify. So when I do the restrictions, I'm just not looking at my final answer. I am looking at the factored form of the original problem. So I'm going to say that x minus 3 cannot equal 0, and that's the one we canceled. We still have to account for it. And I'm also going to say that x plus 3 cannot equal 0. So I'm going to say for my restriction that x cannot equal 3 or x cannot equal negative 3. Those are both restrictions, and again, you could put those with a comma in between instead. You wouldn't need to write x does not equal for both of those. All right, so a couple more examples on simplifying. We're going to now look at example 5. And in example 5, we have, there's nothing we can factor in the numerator. But what we can do is we can factor the denominator. So in the denominator, I'm just rewriting the numerator here. In the denominator, I have a common factor of xy, and I'm going to take that out, and I'm left with x minus y. So here, again, a common factor of x and a common factor of y, and those can both be canceled. So we're going to cross off the xy, and then our simplified answer will be 4 over the quantity of x minus y. Our restriction is going to be 3 different restrictions. And how do I know that just by looking at it? Well, because I have 3 factors, the x, the y, and the x minus y. So my restriction is going to come from the fact that I'm going to set each of those factors and say they cannot equal 0. X cannot equal 0, y cannot equal 0, and x minus y cannot equal 0. So this one you wouldn't have to solve both directions, but if I just added the y to the other side, I would see, I would say that x cannot equal y. So my 3 restrictions in this case are going to be here. X cannot equal 0, y cannot equal 0, and x cannot equal y. All right, our final simplifying example, and you'll have plenty of practice in the homework to come, is already in factored form for us. And the reason is because we want to look at something that happens when we're factoring trinomials. As you can see here, we have no common factors if we look in the numerator and the denominator. However, we have something that is going to allow us to simplify it. If I look in the numerator, I have n minus 3, and in the denominator, 3 minus n. Those are opposites, and therefore we are able to simplify them. What we're going to do is we're going to factor out a negative from one of them. It doesn't matter which one, the numerator or the denominator, so that we get something that matches. So here what I'm going to do is I'm going to take it out of the numerator. So I'm going to make this, again, I'll leave the first term the same, 3n plus 2, factor out a negative 1, and then it becomes 3 minus n. In the denominator, I'm leaving everything alone. And so what I have now is I created the match. We want to look for those opposites so that we can simplify as far as possible. Now in this particular case, what you would probably want to do with that negative is just put it in front of the fraction bar, or you could leave it in front of the parentheses, but this way you can get rid of the parentheses as long as you have the negative right in front of the fraction bar. If you bring it up here and you don't have parentheses, then it's not correct because you would have needed to distribute the negative for it to be equivalent. So just be careful of that. So when we do our restrictions here, we're going to have, again, looking at the denominator, we're going to have two inequalities. 3 plus n cannot equal 0, and 3 minus n cannot equal 0. So here, when I subtract the 3, I get n cannot equal negative 3. And here, I'm going to add the n to the other side because that's a little bit easier. So I'm going to have n cannot equal 3. So again, n cannot equal plus or minus 3, or we can write that twice like I did, but we have two restrictions. All right, so we're now going to look at a couple of solving questions. Oops, I'm sorry, we have one more example. So example 7 is our last simplifying example. And in this case, it looks like I can't factor the numerator, but I'm going to factor the denominator. So what multiplies to negative 24 and adds, or what factor pairs, what multiplies to 24 and has a difference of 2, that's going to be 6 and 4. So I'm going to be able to use a minus 6 and a plus 4. So this is just another example to show us how the opposites work. If I left my answer like this, it wouldn't be fully simplified because I have opposites in 6 minus x and x minus 6. Again, what I want to do then is factor out a negative 1 so that I get, and again, I'm going to put that in the numerator for now. I'm going to change that so that it's x minus 6 instead of 6 minus x. Again, you can see that if I distribute that back, I get what was in the numerator. And then I am able to go ahead and cancel. So now I can cancel these, and I'm just going to make a note here because with that highlight, I want to make sure you remember these are opposites. Right, so, and that's why we factor out the negative 1. So at this point, now because I have, again, no term left in the numerator, I can leave a 1. I would put the 1 in front of the fraction bar, and in the denominator I have x plus 4. That's my simplified answer. Now I'm going to do my restrictions. I'm going to look to the denominator before I simplified, and so I'm going to have two restrictions. X minus 6 cannot equal 0, and x plus 4 cannot equal 0. When I add 6 to the other side, I get x cannot equal 6, and when I subtract 4 here, I get x cannot equal negative 4. Okay, so now we're ready to solve. So in our next example, moving into solving for x, what we're going to do is if we look at what we have is we have three variables, a, b, and x. But what we're solving for is x. So to get the x by itself, we're going to want to factor it out so that we can isolate. On the other side, we can see that we have a perfect square trinomial, and we could factor that to a plus b times the quantity of a plus b. We could then divide both sides by a plus b to get the variable of x by itself, which is our goal. So on the left-hand side, we're left with just an x. And on the right-hand side, because we have a common factor in the numerator and the denominator, we're left with a plus b. So in this one, we would say x is equal to a plus b. Now, it didn't ask us for any restrictions, so we can just leave it like that. So I'm just going to remind us that here we're going to factor the numerator, and then we're going to divide by a plus b. One more example where we're solving, and in this case, again, we have just two variables, excuse me. We have an x and a b, but our x's aren't on the same side of the equal sign. So the first thing you're going to want to do is you're going to want to put the x on one side. And because we already have a positive 4x over here, I'm going to add bx. And then we're going to put the other, the minus 4, we're going to add that to the other side. So we just have the x terms on the left and everything else is on the right. Then we can go ahead and factor out the x. That's going to allow us to isolate, right, or get the variable by itself, the one that we're solving for. On the right-hand side, I'm going to put it in factored form because I know I'm not going to be able to cancel anything unless I'm in factored form. So factors that multiply to 4 and add to 5 would be 4 and 1, so we can factor that pretty easily. And now we're going to divide both sides by 4 plus b. Well, even though it's in a different order, these are the same two terms, b plus 4 and 4 plus b. Again, the order here won't matter because they do have the same signs. So we divided by 4 plus b, and we were able then to cancel out the common terms of b plus 4. And what we were left with is that x is equal to b plus 1. Now, for some reason, I have the restrictions in my notes, so let's go ahead and do them on this one, and then I can go back and look at number 1 to see if we should have done restrictions. So in this one, we would see what we divided by, which was 4b, and say it cannot equal 0. So when I subtract 4, I get b cannot equal negative 4. And if we were to go back and do that on number 1, since I didn't, again, because we divided by a plus b, we would want to make sure that we knew that a plus b cannot equal 0. So in this case, we would have a is not equal to negative b. Okay, so that concludes our last example. Your homework is from both the red book and the green book. Give that a try and bring in all your questions to class.